Okay, so hello everyone. So in this video, I'm just going to show you a couple more rules from section 15.4, rules for matrix multiplication. So the first rule is something which is known as the power of matrices. So this is essentially, it's nothing very difficult. It says that, okay, so if you have a matrix A, and matrix A is a square matrix, okay? So remember what's a square matrix? So a square matrix means that the number of rows in this matrix is the same as the number of columns. So it's a 2 into 2 matrix. So if you have a matrix A, which is this square matrix over here, then essentially it's possible to also find out for example, if someone wants you to find out, okay, what's the value of A cube? What does this mean in the matrix? Well, so it just means that you're multiplying the matrix A 3 times. So essentially, you can raise any matrix to any power. So let's say if this was A square, this would be A into A, right? So you can also do a matrix operation with powers. Okay, the other interesting bit here is something called the identity matrix. So this is a particular matrix which has this form. Okay, so the identity matrix is always denoted by the letter I. Now the identity matrix is a matrix. It's a square matrix, and this matrix is made out of the number 1 in all its diagonals, while all the other elements in this matrix are 0. Okay, so whenever you say matrix like this, where all the elements on the diagonals are 1 and everything else is a 0, this is known as a identity matrix. Okay, so this is a special case of a identity matrix which is 3 into 3, right? Because it has 3 rows and 3 columns. But you can get identity matrices of any square matrix. It can be of any square dimension. So for example, this would be an identity matrix which is 2 into 2. You can think of even more, right? Like, so let's say 1 0 0 0 1 0 0 0 0 1 0 0 0 0 1. This is another identity matrix, right? So this identity matrix is in the dimension of 4 into 4 because it has 4 rows and 4 columns. So this identity matrix is a special type of matrix where all the entries in the diagonal, okay, the diagonals are 1, while all the remaining entries are 0. So this identity matrix, it has a few, so there's this, so it has this interesting relationship with other matrix. So suppose you have a matrix A, okay, so this is a square matrix, okay, this only works, and then you're multiplying this with an identity matrix. So if you're multiplying any matrix with an identity matrix, the result will be the original matrix. Okay, so this is an important result. So essentially, you can think of that, when you're thinking of like in the real number system, the identity matrix is like the number 1, right? So whenever, let's say, if you're multiplying the variable x into 1, what is the result, right? You get x, right? So in the matrix world, if you have a matrix and you multiply it with the identity matrix, the result would be the original matrix itself. So let me just show you a quick example of this, right? So suppose you take the matrix, let's say you have a matrix A, which is 2 0 0 3, okay? So according to this rule, what would this mean? If you multiply A with the identity matrix, which is also 2 into 2, right? So what's a 2 into 2? So this rule says, so you have a matrix A and then you have another identity matrix. So this rule says, if I do A into I, what will I get, right? So think of how do we do multiplication, right? So multiplication is, first you multiply this into this, then this into this, right? So 2 into 1 plus 0 into 0. Second entry 2 into 0 plus 0 into 1. 0 into 1 plus 3 into 0, 0 into 0 plus 3 into 1. Okay, so I multiplied my matrix A with my identity matrix. This is what I get. Okay, so if I solve this, what do I get? This is 2, 0, 0, 3. What did I get back? Notice that I got back my original matrix. Okay, so this is an important rule, that if you have any matrix A and you multiply it with the identity matrix, obviously of the same dimension, the result will be your original matrix. Okay, so try this out, try a few examples of this and see for yourself how this rule works, that A into the identity matrix has to equal your original matrix. It's just but for this part, it's important how to write an identity matrix, right? So again, this recapping, an identity matrix is a matrix where all the diagonal entries are 1 while all the remaining other elements in the matrix are 0, and it can be of any dimension, 2 into 2, 3 into 3, 4 into 4, but all of them will have this same kind of setup, like all the diagonal entries will be 1 while all the remaining elements will be 0. Okay.